Hi all, my name is Sandeep Madisetti. I'm here to present the coursework on human factors in AI module as part of the AI product management course. So the ask here is for us to choose a business problem or a use case from our daily life or our field area, and then do a detailed task analysis where we describe the problem, perform the task analysis, and provide our insights, followed by the user experience design. We'll explain how the users will interact with the proposed solution, and explain how the key consideration of AI product user experience will be handled as part of the product design. Then the privacy considerations, will explain any privacy related concerns stemming from the data collected and how the model uses the data, and explain what kind of privacy laws and the what kind of privacy laws are applicable and what fairness measures will be put in place. Then finally, we'll talk about the ethical considerations, where we'll identify potential sources of bias and explain how the goals of ethical AI will be met in the AI solution. So the problem or the opportunity that I have chosen here is the ability to use ML solution for scoring student responses. So typically assessment organizations, these organizations who conduct these tests or exams to the students on behalf of the education institutions. So, so they receive millions of student responses after the test is concluded. These written responses where the student has to respond to a given question in their own words in a paragraph or two. So assessment organizations will have to hire manual raters who are qualified to go through the student responses, read through them, and then provide a score based upon the scoring rubrics. Now this is a highly manual process, a lot of time and costs involved, uh, and it's challenging because the process has to be completed within a stipulated time so that the results can be published to the student on the scheduled date. Now here, if we can apply an ML model, that has the ability to uh, interpret and read the student responses and provide the scores as per the guidelines, that would be definitely uh, reduce the cost and process timelines and provide a huge value add. Now for this ML solution, the user will be the rater. The task is basically to evaluate and provide scores to the responses. Now here you see presented a detailed task analysis step by step what happens in the entire scoring process. So the trigger here is the student test responses are loaded into the rater's work queue for evaluation. So once the rater logs in their designated queue, they see uh, the each individual record for a student's test response as that are assigned to them. So that would be the trigger once a response is loaded into the queue. Then the next action would be for the rater to open and view each response for evaluation. Once he opens the response, then he will have to retrieve the scoring rubric that is applicable to that particular exam and subject. Then the next step is to retrieve the score matrix so that he has a view for reference, what is the maximum score and the minimum score that has to be given to that particular exam and item. Then the rater would read through the response, then finalize the dimensional ratings that needs to be applied. Finally, he would enter those scores after the evaluation and save the scores. Then he would move on to the next item in the queue. So here the objective is for the rater to complete the evaluation and provide ratings to all the responses that are in his queue, and make sure they are done on the scheduled time so the results can be published. So an LLM based ML solution can be here used to evaluate the student responses and provide scores as per the scoring rubric. The model can also provide some factual information as per why a particular score is assigned to a response. So the solution will basically take up the cognitive load of the rater, where he has to, where the rater has to read through the responses, understand the interpret, and then provide the ratings. So it will take away that cognitive load, and the rating process is completely completed on time, and the scores can be published to the students on the scheduled date. User experience design. So here the raters would be able to view and submit their test responses to the ML model from their queue. Now they will have the ability to view the detailed workflow of the scoring process of the model is working, with the counter information presented explaining the reasoning behind the score. The readers can definitely provide the feedback to the tool if there is an inconsistency in the scoring process. So as the rater would see how the model is interpreting and providing the scores, the rater can obviously understand either he can agree or disagree with the rating. He may override the rating and provide a comment that he would, because he thinks that the rating given is inappropriate for a particular reason, and then he can overwrite or completely disagree with the ratings or approve the ratings if they are fine. So in either way, uh, the user's feedback here is captured and definitely passed back to the model so that it can be refined. So this will eventually the users will be provided with a seamless user experience with visibility, feedback mechanism, affordance, consistency, and more often as a decision support system. So the key principles: the user inputs, feedback loop. As we discussed, the ML system will provide a counterfactual information during the rating process, where the users can interpret and provide feedback on the model's performance. Also, the tool can capture any user actions which are kind of corrective and or updates. For example, the user can always correct or override a rating provided by the system, or completely discard the ratings given by the system. Right? So such actions the tool can capture and pass back as a user input feedback to the model for improvisation and improvement. Transparency. The model shall provide counterfactual information on the rating process, that clearly providing transparency on why and how a particular score is applied for a dimension as per the scoring rubric. So this will enable the user to interpret on the reasoning and the relevance on the scores provided, right? So they know why the model is giving a particular rating to a particular response. So it's clear transparency, and it's up to the rater's choice whether you want to keep or override or discard that rating. Communicating uncertainty. Since the model is trained to present a certain level of confidence on the score it provides based on the legibility and the vocabulary in the test responses, and the model's ability to interpret the response given the word embedding on which it is trained. So in cases where test responses are unreadable or gibberish, the model can clearly indicate that it cannot score, or it can assign a very low probability, given telling the rater that it is unsure of the rating that is provided, based on which the rater can take a corrective or necessary action. So it's clearly, the model is capable of communicating back or presenting back the uncertainty if there is any in the entire process. Privacy considerations. So as we understand now, that model is strictly designed to just to read the response the student has given to a question in the exam and provide the rating. But it necessarily does not need access to any student's PII data or organization's data. So the model is designed to have access only to the student responses in the test, and any PII or internal assessment organization related data is by default obscured to the model, right? It even doesn't need them. So but it is possible that in some cases a student might inadvertently or intentionally or unintentionally might provide some PI related information that may directly or indirectly lead to the identification in the test response itself, right? When he's answering to a particular question in his own words, right? Knowingly or unknowingly, they might indicate some information that may directly or indirectly point to their identity. So here the model is smart enough to parse that information before passing into the scoring engine to see if any such information is there in the response, so that it can mask it or filter it out before passing it to the scoring engine. Now in some cases, when a piece of information is removed from the response or masked from the response, right, then the entire student response itself might become, you know the word embeddings can lose out of sense, and it might be difficult for the model to score that particular response. So in which case the model will clearly indicate the uncertainty in scoring, because now that information has been kind of manipulated, because the model tried to remove part of the response because it has a potential to be PI, in which case the model might give a low probability to the score it has provided, or it may clearly say this particular response is now unscorable, so that the reader can manually score it. In either way, the model is smart enough, and by design it is architectured in such a way that A, it doesn't need any PI related information for it to score the response. 2, inadvertently, if it found something in the student responses, it is smart enough to identify and mask out that information. How will we communicate to the users of the ML system? So basically, the educational institutions who consume these services, or who are the end users of this process, right? So they'll be clearly communicated how will the model use and process the information. This model would definitely have end-to-end encryption processing with the inbuilt data communication, and that will be communicated. How the data will be stored, retained, and disposed in the system. So basically, it's definitely not an edge-based solution, it's a cloud-based solution, because the responses can be processed via batch offline mode. It will be a cloud-based ML solution and will be stored in the cloud, and the information will have its own cloud-based lifecycle policies, where they can be defined in agreement with the educational institutions how they want us to handle information, and data will be retained, disposed, and managed accordingly. The security measures and design in place, and how the information is secured. So all necessary cloud security protocols will be applied here, so that none of the information is compromised and enough network security measures are put in place. Now, since the assessment organizations, they can operate locally or globally, catering to a wide set of education needs. So here the ML system will be designed in such a way that it complies with all data privacy policies and laws and regulations at both levels, national and international. So right, for example, in the US, the system must comply with the local data privacy laws like CCPA, and Europe, for example, in Europe, it has to comply with the GDPR policies, right? Now again, since the model is applied in educational domain, it has to also comply with the FERPA, which is the Family Educational Rights and Privacy Act. So the model is designed in such a way that, depending upon where it is used, applied, and operated, the necessary privacy laws are complied, and the design also takes care of them as it's built. Finally, the ethical considerations. Since the model leverages your fundamental LLM model as a backbone that can interpret natural language responses, and it's further trained on the historical student responses and scores. So it has the potential to inherit a learning bias, because as the word embeddings on which it is trained can lose relevance with respect to the current lexicons and the vocabulary used by the current education system, students, and society in general, right? So this can have impact on how the model will interpret the student's response and accordingly provide the scores. So here the model will be designed to meet the ethical goals of AI. So in fairness, so the model will be designed such that it is expected to deliver fair outcomes for all groups and types of students, with a balance between group and individual bias. The design and architecture is expected to mitigate any learning bias by consistently training and updating the model through continuous feedback loops. As we discussed in the previous slides, there is always a feedback loop and a decision support system in place, where the readers and the users are able to view the reasoning behind the model on why it provided a particular score to a particular response, and the ability for the user to either to accept, modify, or discard those ratings, and also that feedback is passed back to the model so that it is improved and improved. Accountability. So the assessment organization here will be accountable for the scores and the output delivered by the model, right? So they own the complete accountability. So any concern from the educational organizations or the student parent community on the final output, which is the student scores, will be investigated and necessary feedback loop will be established to keep the model updated. Transparency. The model users will have visibility in the who have visibility into the data usage as how the model is interpreting and processing the response data and the LLM engine behind it. So the model is also provides a counterfactual information for each of its score, right? As we discussed that the model clearly tells why it gave a particular score to a particular response, so the users can understand the reasoning behind why such a score is generated. So there's a clear transparency in the model functioning, and the users have the visibility into the data that is being used and how it is used. That concludes the presentation. Thank you very much for your time. Much appreciated. Bye.